All right, so today we're going to talk about stoichiometry. So this is the first part of stoichiometry. So the first thing you need to know is what is stoichiometry. All right, stoichiometry, guys, is simply the relationship between the relative quantities of substances taking part in a chemical reaction. All right. So typically, guys, what we're talking about when we say stoichiometry is the ratio between compounds in a chemical reaction. Specifically, we're looking at their coefficients, right? So let's take, for example, this one right here. So if you look closely at this chemical reaction right here, you can clearly see that for every 4 molecules of Fe, you would need 3 molecules of O2, and that would form 2 molecules of Fe2O3. Or you can also read this as for every 4 moles of Fe that you use, you also need 3 moles of O2, and that would form 2 moles of Fe2O3, right? So that's basically the relationship between these three. So if you want to focus only on two things, right? Let's say we want to look at Fe and O2. What is the ratio between them? Well, for every 4 moles of Fe that you use, right, you would use up also 3 moles of O2. Okay, see that? This is what you call, guys, the mole ratio. Okay, so this one right here is called the mole ratio. So look at the question right here. What is the mole ratio between Fe and O2? We just answered it right here. Okay, that's the mole ratio between those two right there. Okay, and we can write down the mole ratio in two ways. All right, we can say for every 4 moles of Fe, okay, we would use 3 moles of O2. So this is 4 moles of Fe per 3 moles of O2. Or you can write it down, the other way around. For every 3 moles of O2, okay, you would need 4 moles of Fe. So again, guys, when we talk about the mole ratio, all right, we're just looking at the coefficients, right? So we're just looking at the coefficients of the substance, right, in the chemical equation. Now remember, the chemical equation has to be balanced, and that's the key there. It has to be balanced, all right? So let's take, for example, the question was slightly different. What is the mole ratio between Fe and Fe2O3? So this time, guys, we're looking at Fe, right, and Fe2O3, these two right here. Okay, so look closely at their coefficients, right? For every 4 moles of Fe, okay, we would produce 2 moles of Fe2O3. So we can read the mole ratio as 4 moles of Fe per 2 moles of Fe2O3. And again, since it's a ratio, you can flip this over. Okay, you can go like, or for every 2 moles of Fe2O3 that is produced, we use up 4 moles of Fe. All right. Someone's going to notice this. Oh, Mr. Chua, can't we just say for every 2 moles of Fe, we use 1 mole of Fe2O3? Is that correct? So, for example, some people would write this down in the lowest term. So they go like, this would be a 2 and this would be a 1, right? You can, but there is no need. So again, you don't need to simplify this, right? You just need to look at the equation and get the numbers exactly as you see it from the chemical equation. Again, you don't have to simplify the mole ratio, right? It's a good thing that you know that 4 over 2 can also be written down as 2 over 1. But again, there is no need to simplify it, okay? All right, so mole ratios are fairly easy, right? Fairly easy, right? If they are just looking at the ratios in the chemical equation, right? The problem is, what if it's not looking at the ratios? They're not whole numbers based on the equation, right? And that's the problem right there. So look at this problem right here. How many moles of Fe2O3, right? So look, is formed if 1.5 moles of O2 is used up. So we're given, right? So let's write that down. So our given here is 1.5 moles of O2. You all see it? Okay. In our unknown, what we're looking for is moles of Fe2O3. So look, the question is how many moles of Fe2O3 is formed if you have 1.5 moles of O2, right? If you look closely at the equation, guys, if you look closely, I mean at the problem, we're looking at two compounds here. What we're looking at is Fe2O3 and O2. So let's look at our chemical equation and find out where they are. It's right here, O2 and Fe2O3. Okay, it clearly shows in the problem that for every 3 moles of O2, you would need 2 moles, I mean, you would produce 2 moles of Fe2O3. But the question is not that. It's only asking you what if this was 1.5. Okay, what would be the answer here? Okay, all right. If you look closely, it seems that we just divided the amounts in half. So 3 becomes 1.5. So it's like dividing it in half, right? So you would say the answer here would be 1 mole of Fe2O3. And that is actually a correct answer right there. How do you do this? How do you show this using a correct format? Okay, so let's see. Remember the boxes and the squares that we did before? Okay, we're gonna need that again. So again, remember boxes and squares. There's nothing here. Okay, and the given goes in the very first top box. What is the given again? 1.5 moles of O2. Right. Okay. Now what goes in the next two boxes? All right. Remember, guys, what goes in the next two boxes is a conversion factor, and that's going to be our mole ratio. So again, our mole ratio. So if you look closely at this one right here, the mole ratio is between O2 and Fe2O3. So 3 moles of O2, right? And 2 moles of Fe2O3. Remember, this is our ratio, right? Okay. The question now is who goes on top and who goes at the bottom. By now, you should know that boxes across one another should have the same unit. So since our given is moles O2, the 3 moles O2 has to go at the bottom. Okay? And therefore, the moles, the 2 moles of Fe2O3 goes on the top. Look, let's solve this. Moles O2 will cancel out, right? You can multiply the boxes at the top. 1.5 times 2 gives me 3. And then write down whatever's left behind. Moles Fe2O3 over multiply everything at the bottom. It's just a 3. 3 divided by 3, the answer is simply 1. So the answer is 1 mole of Fe2O3. Give me a second. All right, so let's try another problem with that. Okay. So for example, the question is how many moles of Fe2O3 is formed if 1.5 moles of Fe is used up. So this time, guys, the given, all right, let's look at this one right here. So the given here, the given here, there you go, the given is Fe, and it's 1.5 moles Fe. Right. So what I do is, okay, and this is just me, all right. As soon as you get the given, find the compound in the equation that corresponds to your given. So we're looking at Fe. Fe is right here. You see it? All right. So now let's look at our unknown. How many moles of Fe2O3? So our unknown is moles of Fe2O3. All right. So if you look at that right there, let's find it in the equation. Fe2O3 is right here. All right. Just put a box around it. Okay. And those are the two compounds that you need the mole ratio. All right. And that's going to be what goes in the next two boxes after your given. So let's do our boxes and squares again. So again, to set this up, draw your boxes and squares. Again, there's nothing that goes here. The given goes in the very first top box, 1.5 moles of Fe. Right. So what goes in the next two boxes? Again, guys, that's your mole ratio, and the mole ratio comes from your equation. This is your mole ratio. Don't forget. And how do you know, again, which two do you look for? It's, again, your given, which is Fe, and your unknown, which is your Fe2O3. So you look for your given and your unknown. So again, who goes on top and who goes at the bottom? It's very simple. Again, remember, boxes across diagonally should have the same unit. Since the given is moles Fe, the bottom here should be mole, okay, Fe as well. Right. So look at your given. I mean, look at your mole ratio. Which one is the Fe? It's the 4. So that's 4 moles Fe. Right. I'll show you a shortcut, by the way. You don't have to write down the mole Fe in the conversion factor. So I can just write down, and this is the shortcut, right? 4 Fe, exactly as it shows in the equation. Why? Because if you look closely, it's going to be just the Fe that cancels out. So if we cancel out stuff, it's just going to be Fe that cancels out. See it? All right. So what's going to be on the top? It's going to be the 2 Fe2O3. All right. Now look closely. I multiply the numbers 1.5 times 2. That gives me 3. And then I need to write down whatever words are left behind. So if you look closely, moles is left. So I need to write down moles first. And then on the top, Fe2O3, the compound itself, is left behind. So I need to write that down. Fe2O3 over, and do everything at the bottom, but there's only one number at the bottom. It's just 4. Okay. See it? So get a calculator. 3 divided by 4 is simply what? 0.75. All right. And then the unit will be moles Fe2O3. And that's how you do this thing. You see it? All right. So do all the practice problems in the Canvas page, the assignment in the Canvas page. And if you have any questions, just hit me up in the chat and I'll help you with stuff. All right.